You see what we did the other day was we talked about it if the number of the data values, if you have very a small sample, if you like, if you have very a small sample and if you have a couple of samples, and if you want to compare their distribution together, then we are going to use the so-called box plots. So the box plot is the one that contains 5 different numbers. Okay, this is the one that we did the other day. We have 5 numbers. The numbers are going to be minimum, Q1, Q2, Q3, the quarters, and the maximum. So we put those numbers on the number line, and above the number lines, we are going to connect these quarters together, quarters, to get a box. Then this is going to be min and the max. Then in order to find out what the situation is going to have, Q2 is the center of your data set, and this red one, there is a center of the box. So you compare your data values to the center of the box. If you are very much close to the center, so that's the best case. So this means your distribution is symmetric, 50% to the right, 50% to the left. Whatever you have, these values is going to be, it's a very fair and nice result. But sometimes you may have the other way around. Okay, so that's the description that you're going to have for the box. So the first case is going to be the centers, both centers are close to each other. So that would give you a symmetric distribution, 50% to the right, 50% to the left. And we're going to get the graph on the chapter 5. Then that give you a better understanding of what we are talking about, 50% to the right, to the left. Then your center maybe falls to the left or to the right. You may have a shifting to the right or to the left when you compare it to the middle of the box. For example, in this case, you shifted to the right. So this means your distribution, your numbers are not going to be symmetric, if you like, because you don't have the 50% to the right, to the left when you compare it with the box. So we say your distribution is skewed. Okay, it's going to be skewed, you shift it to the right. So as in algebra, we are going to say that you are negatively skewed, if you like. So that is going to be shifting to the right. This is the negative one. Okay, that's a negative one. The other one is going to be positively skewed. And you can find the outliers and those type of ideas that we talked about it before. But when it's a test, we just divide it in 2 problems. One problem just finding the outliers, IQR, etc. The other one is just describing the box. But in the problem in your book or on the web, they may ask for all of them. Okay, so I'll just give you one example. We usually give you one example on next quiz and the test, and even we check it on the final. This is something that is good to remember. Okay, so the example is going to be, and again, this Q1, Q2, Q3, can you find it by your calculator? The way we did it to find the standard deviation, the mean, automatically give you the Q1, Q2, and Q3. And it's not difficult to find it manually if you like. Okay, so it's going to be example that we're going to have. We are going to check the data sets containing a sample of 20 people. These people are watching TV, television. Okay, and we want to see how many hours we have the information of how many hours they are watching TV sets, okay, TV programs, and then we want to get the distribution and box plot of these ideas. Okay, so I have to write it down. So this is it, the weekly, okay, weekly TV, television, TV viewing or watching or the viewing times for a sample of a sample of 20 people. 20 people are displayed. Okay, displayed in the following table. following table. Okay, would like to construct the box. Okay, construct a box plot. Construct a box plot and make a comment. Make comments regarding, you know, the distribution. Comments on the distribution. Okay, sometimes, you know, some questions would be proposed regarding to the box, and then you can compare it and answer it when you get the problem in your book. Okay, so there are going to be 20 numbers, and these are going to be number of the hours. Okay, that's it. We got the 25, 25, 41, 41, 27, 32, 32, and 43. And then you get a 66, 35, 35, 31, okay, 31, 15, and 5. So that gives you 34, 26, 32, 38, and 16. So that's going to be 30, 38, 30, 20, and 21. So these are the numbers that we have. So we have to find the Q1, Q2, Q3, minimum and the maximum, those 5 summary numbers. And if you drop it in your calculator, the calculator will give you the numbers right away. The same thing that we did for the standard deviations. Okay, but it's not difficult to do it. So if you want to do it, so you have to order the list. Okay, you are going to order the data set. Order it from the smaller number to the bigger one. And if you check the smaller number, it's going to be 5. And then you just keep going. Okay, so I give you the ordering. Make sure to get enough space for 20 numbers. Okay, so this is it. It's going to be the ordering. 5, 15, 5, 15, 16, 20. Okay, 20, 21, 25, 26, 27, 30, 30, 31, 32, 32, 34, 35, 38, 38, 41, 43, and 66. So these are going to be the ordering of the data set. Now the number of the observation is 20, it's even number. So in order to get the Q2, 10 to the right, 10 to the left. It's an even number, so you have to find the, okay, find the median by finding the average of the 2 central elements. Okay, so there you are. I have the n is equal to the 20, which is an odd even number. So 50% to the right, to the left, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is going to be 10. Okay, so this is going to be 10. And this is going to be 10. So in the middle, since it's even, you don't have anything, so you get the Q2 is going to be the average of the 2 middle ones. It's going to be 30 plus 31 over 2. That's a 61 over 2, which is going to be 30.5. Okay, that would be the Q2. Then you go to the left and the right, you have 10 members, again, 5 to the right, 5 to the left, okay, to get the Q1, 1, 2, 3, 4, 5. Okay, and 1, 2, 3, 4, 5. Since it's even number, there's not going to be anything in the middle, so you have to find the average. So the Q1 is going to be 2125 divided by 2. Okay, that give you 46 divided by 2, make it to the 23. That's going to be 23. Okay, we do the same thing here. 1, 2, 3, 4, 5. And that's going to be 1, 2, 3, 4, 5. Nothing in the middle. So the Q3 is going to be the average. Average of the 35 and 38 divided by 2. So that gives you 73 divided by 2, which is going to be 36.5. Again, calculator give you the result right away. The minimum is 5 and the maximum is 66. Okay, so we're going to give us the 5 numbers, the 5 summary number or 5 number summary. And the minimum is going to be 51. The Q1 is 23. The Q2 is 30.5. And the Q3 is going to be equal to the 36.5. And the maximum, okay, and the maximum number is 66. So that's the 5 number summary that you have to find it. Any question? Draw a number line, take these numbers on the number line and construct a box. Okay, so the last number that I have is 66. So I get this line here and I divide it into tens. Okay, so this is 0 and 10. Then this is going to be 20, 30, 40, 50, 60, and 70. Okay. So identify the numbers and you know that you just put a small vertical line on the top to construct your box. The minimum is 5. So this is going to be 5. So you draw a line here so that you make a box from this line, vertical one. Then the Q1 of 23 is going to be 1, 2, 3. So that would be your Q1. Okay, this is going to be Q1 for the 23 here. Then Q2 is 30.5. So this is going to be 30.5. So this number is going to be your Q2. Okay, 30.5. And that is the Q2. Then the Q3 is 36.5. 36, okay, suppose this is 35, 36. So that gives you Q3. Okay, so this number is 36.5. Just wanted to give you a hint of where the number is. And the max of the 66. So this is 65, 66. So that would be 66. Okay, you are going to collect, you are going to connect the quarters together to get the box. So this is going to be the box. This is the box and connected to the max or the min. So that would be your box plot. Any question? Now, this is the Q2 that you got over here, and then you compare it with the middle of the, okay, middle of the box. Middle of the box would be almost here. Okay, so this is going to be the box. And you know that if you want to, if they are very close, if you are any doubt about it, you know that this is going to be Q3 minus Q1. This is interquartile range. So we can find the Q3 minus Q1 and divide it by 2 to find out, you know, that you got it right. But it is mostly, you know, easy to find. So the middle, your center is to the right of the center of the box. So this means your distribution is not symmetric. is not symmetric, it's shifted to the right or skewed to the right, which is negatively, okay, skewed. So just explain it and then you that. So the explanation is going to be that the distribution, okay, the distribution is not symmetric. So those number of the, okay, overs are not just normal, if you like. The distribution is not symmetric. It's okay. It's to the left. It's to the right. So shifted to the right. So it's skewed negatively. It is negatively, okay, negatively skewed, or skewed to the right. Both of them would be fine. So this means, you know, there's going to be some people over there that they're viewing TV or TV program too much. That's why you didn't get, you know, you didn't get the symmetric one. Okay, so this is how we describe the box. And as I told you, it's going to be a good one because if you have a couple of data, okay, you're just doing something and you want to change the procedure. So if you have a couple of them, you are going to draw two boxes here and you compare the boxes together. And, you know, it's like when you're producing something, you know, you're producing, for example, the regular cheese, and then you are going to be producing the non-fat one, for example. So you have the information related to both of them, and then you want to compare them together. So you get one box for the ordinary regular cheese and the other one for the non-fat one. So you have all the information visually, and you can compare and, you know, and get those numbers. So that's it. That's something that's fun to do it. If you do it with your calculator, the calculator usually give you in this form. Okay, give you a vertical format, which is, you know, which is, even if you do it, we accept it, but on the test or on the quiz, you have to draw it for us, okay? You can get the Q1, Q2, Q3 from your calculator if you like, we accept it, but you have to draw the box and make a comment. In that case, your question is done. Okay, that's box plot. We give you one to practice. When I post your practice quiz number 2, there are 2 to take care of. And then one of them would be given to you. Okay, it's not a big deal. Any question? So we are done with the first part of the course, which was descriptive statistics, and we introduce all the measures mostly related to the sample. So we want to get through these and make a prediction for the property of the population. To get to that one, we need a machine. That machine is a function, a special function. That the special function is called probability. So that's why we are going to study probability. Okay, so we're done with chapter 3. Chapter 3, we get to the chapter 4. Okay, the chapter 4 is going to be foundation of the probability. For the rest of the course, we are going to use probability quite a lot. But what we do, we introduce the probability first. We use the so-called basic one or the classic probability. When it's a classic, you know that everything which is classic, there is a boundary, like classic literature, classic music. So it would be the same with this type of probabilities that we're going to introduce. But as we move on, we improve this machine. Okay, we improve it, and eventually we change it to the nice algebraic format that can be used easily. So you got to be patient to get through this chapter, and then as we go on, we make it easier for you. Okay, so let's see what we need to know about the probability. So it's going to be a couple of definitions because this is something new to start with, then how we're going to work with it, what is the property, and etc. Okay, so we are going to check the probability. So this is going to be, we call it foundation of the probability or fundamentals. Okay, what is going to be fundamental or foundation. Fundamentals of probability. The basic fact, if you like, about the probability. You see, probability is going to be a procedure, an action, a function, a procedure that produces some outcomes, okay, some outcomes, some results, but this result depends on chance. Okay, it's a chance procedure, it's a random procedure, This means if you toss a coin, okay, there are two possibilities. You may get head or you may get tail. So it's a procedure and there are outcomes. The outcomes going to be head or tails. But how we're going to get head or tails, there is a 50-50% chance that you may get a head or you may get a tail. Okay, so let's give you the definition. There's going to be definitions, so terms that we're going to use. Eventually, we are going to introduce it as a function. Okay, so what's a probability? A probability. Okay, a probability experiment, we usually refer to it, or procedure. Okay, procedure is a chance process, a random is the chance process that resulted or leads, okay, leads to well-defined result. Okay, well-defined, well-defined, or to add here, well-defined results that we are going to call them. Those results are going to be called outcomes. This is one of those expressions that we have to know from now. Outcomes. Okay. So the examples that we are going to be mostly using in this part of the course are going to be, okay, for example, these are going to use. Rolling, the first one is going to be, okay, rolling a die is going to be one of them. Okay, the other one is going to be drawing a card from a deck. Okay, drawing a card from a deck of cards, or flipping or tossing. Okay, that's going to be one, flipping a coin. Mostly these are the ones that you will see in this section. Okay, these are going to be, of course, our examples are a probability. They are going to be probability experiment. Okay. You know that if you roll a die, there are 6 possibilities. Number of the spots that you're going to do. You have 1, 2, 3, 4, 5, 6. When you draw a card, there are many possibilities. In a deck of cards that we're going to use, there are going to be 52 cards. There are 52 possibilities. You know that you may talk about the color of the cards and the type of the cards, okay, and the queen, you know, the king, queen, aces, etc. And if you flip a coin, there are 2 possibilities, head or tail. So these are going to be the case. Okay, any question? Now we go on giving more terms of the probability. We already talk about the outcome. So, you know, if you're rolling the die all the time, so, and each time you are going to have some outcome. So officially, I'm going to talk about it again. So an outcome Okay, and outcome is going to be the result of one trial. Okay, it's going to be the result. It's going to be the result of a single trial, single repetition, if you like, of an action. A single trial of a probability experiment. As we talk about, tossing a coin, the outcome is going to be head or tail. Now, if you collect a set of these outcomes, okay, put a couple of them together, the result is going to be an event. Okay, so the next expression, important expression, is going to be this is it, a collection, a set, a collection, a few, okay, a collection of outcomes is going to be called, okay, it's called an event. An event. Okay, for example, if you toss a coin, an event that you get a head, that would be an event. If you roll a die, okay, and you'd be interested in even numbers only, so if you get the 2, 4, and 6, that would be an event that you get the even numbers. An event that you get an odd numbers. Okay, so it's going to be the one. You draw a card, maybe your event would be the one that you like to get a king. So that would be an event. Okay, so the events are going to be our tools. We usually denote them by uppercase letters. So the events are going to be denoted by the symbol like A, B, C, etc. So that would be events. Okay, any question? Now, if you collect all the possibilities, means the collection of all the outcomes, the result is going to be called the sample space, the sample space of that experiment, which is very important term. Okay, so the collection or the set and the collection of all, okay, of all possible, collection of all possible outcomes. All possible outcomes is called, okay, this is going to be called the sample space. Sample space. Sample space is denoted by the uppercase S. It is denoted by uppercase S. Lowercase s, that means standard deviation in the statistic. But if you use upper, okay, the upper letter S, okay, or the big one, in that case, this is going to be called the sample space. It's important for each case that you be able to identify the sample space in order to do the job. Okay, any question? So if you pick a couple of outcomes together, result together, you are going to have an event. If you collect all of them, all the possibilities, okay, you are going to have a sample space. The result of each trial, if you like, each time, that give you an outcome. So let's get some sample space of some famous examples that we may have to deal with. Okay. So example, you want to identify the sample space of each case. Okay, so identify the sample space the sample space of the given probability experiment. The one that mostly you have to use for the problems that you have in this section. The first one is rolling. Okay, rolling one die. Rolling one die. You want to identify the sample space, you have to give us the possibilities when you roll a die. So what's going to be the possibility? You know that the possibility is going to be one. You get one spot, two spots. Okay, 1, 2, 3, 4, 5, 6. So this is going to be the sample space for the rolling one die. 3, 4, 5, and 6. Okay, so it's going to be sample space for this case. Any question? So when you have a sample space, then you can, propose other questions. So if you pick any sub collection of these numbers, you have an event. Okay, so if you put the 2 and the 3 together, this is an event. But if you put all of them together, that would be the sample space. Okay, any question? So the next one is going to be, let's say, tossing or flipping one coin. That's clear. If you toss one coin or flip one coin, you have two possibilities only, head or tail. So in this case, the sample space is going to be what? It's going to be head or tail. You have two possibilities here. Any question? This third one is interesting. You have one question on this one on your assignment. 1, 2, 3. So number 2, you toss one coin. How about 3 coins? Okay, so what's going to be the sample space for this one? If you're tossing 3 coins. So we want to know what's going to be, or how many possibilities are going to have. You know that each coin would have 2 possibilities. And you have 3 coins. So 2 possibilities for the first one, 2 possibilities for the second one, and 2 possibilities for the third one. So you should have 8 possibilities to get, to get the result. Anybody wants to try? What is going to be the sample space? But it's going to be those 8 possibilities. Each coin would be, maybe would result in a head or tail.
Wouldn't it be 6 possibilities? And it would be,
No, it would be 8 possibilities. Because in each case you have 2 possibilities. 2 possibilities for the first one, 2 possibilities for the second one, 2 possibilities. We have something we call it product rule. 2 times 2 times 2 would be 6. The set point of view. You can list it. You have to list it. Let's try list it to see how many do we have. 3 coins. You toss 3 coins, and each one of them would have head or tail, head or tail. Anybody want to try? Suppose you do it, if you toss a coin once, so the result is going to be this one. You see, you may get on the first part, you may get a head, a tail, if you like. Second one would be the tail, and this would be the tail. That's the first possibility, or one possibility. What's the others? So the first one is tail, tail, tail.
You could get tails, tails, heads.
Yes. Tails, tails, head. Yes.
And you could get tail, heads, heads.
Tails, heads, heads. Yes.
And then you could get 3 heads. Heads, heads, heads.
Heads, heads, heads. Yes.
And then heads, heads, tails.
Head, head, tails. Anything else? Somebody said head, tail, tail here. We have it. Kyle, head, tail, tail. Yes. Then anything else? Head, tail, head. Somebody, who's that? So we have a head, tail, head. How many do we have? 1, 2, 3, 4, 5, 6, 7. We need one more.
Tail, head, tail.
Tail, head, tail. Yes, you are right. Tail, head, tail. That's it. You get 8 possibilities. There is no other possibility you get. See, 1, 2, 3, 4, 5, 6, 7, 8. It's going to be 8 possibilities. You see, it's an action that each action would involve 2 possibilities. You see, 2 possibilities for the first one, 2 possibilities second, and 2 possibilities for the third one. So if you want to do it, all of them together, it's going to be the product of the possibilities, 2 times 2 times 2, which is going to be 8. Okay, so you have the 8 possibilities over here. And you have a couple of problems on this one. Then you have to know the sample space. You have to know sample space, and we come back to it in, later. Okay, any question? So that gives you an idea of what we mean by the sample space. When a situation arrives, we have to find the sample space first. The sample space is going to be all the possibilities. Then we are going to have various questions in future. For example, you may be interested in to see, okay, how many times are you going to get only one tail? You see, for the one tail, you get one tail here, one tail here, and the one tail here. So that gives you, an event that we talk about. But you have to get the sample space first. Okay, any question? Now we have the alphabet, but what is we haven't defined probability. So what do you mean by the probability, okay, of an event? So this is what we are going to do now. So the main question is going to be, what is going to be probability chance? Okay. Probability of a given event, of an event. Now, what we are going to do is, the way we think about it, probability is going to be a function. And you know that the function is what you put this is going to be your event. You say that's going to be your event A. So what you're going to do, you are going to drop it into the function machine. So the function would be the probability. So the output must be probability of A. Probability of A. You see, that's going to be bad. So suppose the event is having rain tonight. So probability of having rain tonight, you may say it's 30%. So that probability of event is going to be 30%. So this means there is 30% chance that it's going to be raining tonight. At the same time, you know that there is going to be 70% chance that we are not going to have rain tonight. So from a definition point of view, is notation point of view. So if A is going to be a given event, is going to be a given event, then the probability of A, then the probability of getting A or having A is going to be denoted by, okay, it's going to be denoted by P of A. So that's going to be the definition and notation they're going to have. Okay, but the question is going to be how we're going to find it. Okay, so how we're going to find the P of A. In order to find the P of A, we have 3 cases. Okay, and then eventually we have we have formulas. But some people, they say there are 3 types of probability. They are not types. They are the way you are going to get this event, okay, to get the probability. Now, there are 3 methods, or you can say type. There are 3 methods that we can find this probability. 3 methods to find the probability of A. Okay, what are going to be the methods that we're going to have? The first method is going to be called classical probability. This is just a kind of history of the probability. So the first one is going to be classical probability. Classical probability. The second one is called a relative frequency. Okay, relative frequency probability. Okay, probability. That's going to be the second one. And the third one is something we call it subjective. Okay, subjective probability. So these are going to be 3 ways that that we may have to use in order to get the probability of the given events. So I'm going to explain each one of them to see how we're going to find it, or where are you going to use it. Okay. Now, the first one, classical probability. You see, when something is classic, means there is a boundary, okay, that you have to consider, and you're not going to question it. In the case of the probability, classical probability, we assume that all these outcomes would have an equal chance to occur. So this means that if you toss a coin, you are going to accept it that there is 50% chance. You get a 50% chance to get the head, or 50% chance to get a tail. Okay, unless you're cheating, if you like, and if you have a regular coin, this must be the possibility. So you're not going to question this one. You're not going to question that, how do you know that it's going to be 50-50? We accept it. So in that case, this is going to be called classical probability that you're going to have. So the way we are going to find it is very easy. It's like a percent. So you have an event and you have the sample space. So the ratio of the number of the elements, or the number of the possibilities in an event or outcomes, divided by total number in the sample space, that give you classical probability in this case. Okay, so to write it down as we go on. And this is the first time that they create the probability. This was created for the people, to help those casinos or gambling, office, if you like. And they want to make money, so they hire some of the famous mathematicians. And the mathematicians like Fermat and a couple of other people, they were looking for a job. So they were hired by these casinos, to just give them information, probability information, help them so that they can make money. So that's just the beginning of that classical probability. So let's talk about that classic first, okay? I'm going to give you something related to each one of them. Classical probability. You are not going to question the, questioning the action in this case. You just accept it. We call it a classical probability. In some books, they call it expected one. Okay, if you like these expressions, expected probability. As you know it in advance that, you expect this one. And now, what is going to be the case for the event A? And this is it, probability of A is going to be equal to, remember A is an event, so it's a collection of outcomes, the members. So what we're going to do is you are going to get a ratio here, a fraction. On the top, you count how many members can you see in A or how many outcomes. So the top would be number of, number of outcomes. Will be number of outcomes in A. Okay, divided by the total number of the outcomes in the sample space. Total number of outcomes in the sample space, sample space S. Okay, number of the elements, number of the members A, or the possibilities divided by the total number of the possibilities. That would be probability of A that we are going to use, but in short, this is it. P of A is going to be, this is the notation I'm going to use. I use N of A. This means a number of the elements in A. And divided by N of S means the number of the, the number of the outcomes in A, the number of the outcomes in S. That would be classical probability, or the way you are going to find the probability. You may call it probability. Okay, and so N of A means the number of the elements in A. N of S means the number of the elements in S, the number of the outcomes. In some books, they use this notation. I'm not going to use it. Probability of A. They write something like the absolute value of A divided by absolute value of S. But we say absolute value when it's a number. A is what? A is a set, is a collection of sets. And in a set theory, this notation is called cardinality, cardinality of A and cardinality of S. Cardinality is the same as this one for these sets, of course, So this basically means the number of the elements. So I'm not going to use this one. I don't want to be confused. Okay, so I'm not going to use the other one, but use this notation. The probability of A is going to be number of the element in A divided by the number of the element in the sample space. Okay, any question? So this would happen for very limited cases that we have, tossing a coin, drawing a card, rolling a die. All those examples that I gave you can be done by using this formula. Now the result's going to be a fraction. You've got to be careful. You have two choices to present the result to us. If you want to stay as a fraction, you must make sure you simplify it, the top and the bottom. If they are divisible by 2, 3, you can simplify it. The other option, which is we prefer, is the calculator. If you use the calculator, the result's going to be in percent. In percent, that gives a better understanding when you want to compare it with some other situation that we have. But on the test and the quiz, you have two options. If you want to leave it as a fraction, make sure you see. For example, if you get 2, 6, 2 on the top, 6 on the bottom, you simplify that, give 1/3. So the probability would be 1/3, not the 2, 6, if you like. But otherwise, you can you can use your calculator, or sometimes you can run that to get these numbers. Okay, any question? Let's give you some examples how we're going to operate with this one. It's very classic, and we are going to use it to do most of the problem in this section or in this chapter, basically, but then we change it into something else. So very standard example, like the one that you probably will see. So the first one, I draw a card from a deck and I want a king. So for a card, okay, for a card drawn, it's going to be drawn from an ordinary deck, ordinary deck of cards. Ordinary one means no cheating, you know, that we have 52 cards in it. For a card drawn from an ordinary deck of cards, find the probability. Okay, find the probability of getting a king. Okay, you have to write the formula for this, okay? Don't just say the numbers, we don't accept it. You have to give us which formula did you use. Okay, so the solution is going to be, your event is going to be, you see your event is getting a king. So there's going to be an event of, okay, getting a king from that, you know, a deck of cards when you draw one card. Then you write the formula. You see the formula is probability of A. It's classic probability. Number of the possibility to get the A and the number of the possibility for the sample spaces. Okay, how many kings do we have in a deck of cards?
4.
4. So the top would be 4. And the total number of the card is 52. It's going to be 4 over 52. You simplify that, give 1 over 13. And you're done. Okay, so the final answer is going to be 1 over 13, not 4 over 50. That's it. So the chance is 1 out of 13, if you like, to get a king when you draw a card, and you're done. Any question? So this is, this one case, quite a lot in your book in this section, but in future we are going to have a collection of them that we're going to use in one problem. And the other one is rolling a die. Okay, rolling a die or one die. We want to find the probability. You see, find the probability of getting, okay, getting an, let's say, even number or odd number. You know that if you roll a die, you get 1, 2, 3, 4, 5, 6 possibilities. So again, you introduce your event. So A is going to be an event of getting an even number. So in this case, you know that the possibilities are going to be, you may get a 2, 4, or 6. That's going to be your A. And the sample space, there are 6 possibilities. So 1, 2, 3, 4, 5, and 6. 6 possibility for your sample space. So the formula is going to be probability of A is going to be number of the cases in A, outcomes in A, number of the outcomes in S. So you have 1, 2, 3 on the top. The 1, 2, 3, 4, 5, 6. So simplify that, give you 1/2, which is like 50% if you like. That's easy, we can check it. So the probability of A, again, it's okay to write 1/2 or you can write 50%. So there is 50% chance that if you roll a die, you may get an even number of spots. Any question? So that would be the case for rolling a die. Give you one more example, then I'll give a break and we do the other part after the break. Okay, this example, you have a couple of problems again in your book. You want to make sure we are all right with this one. This is it. If a family, okay, if a family has 3 children, has 3 children, find the probability. Find the probability. Find the probability that all the children are girls. That all the children are going to be girls. You have a various possibility of this one in your assignment or the problem that you have on your book. Okay. So we have 3 children. So this is going to be the case again, solution. Okay, 3 children. You want the girls, so the S would be the possibilities that we can have for the 3 children. It's like the one that we did for the coin. So you may give all of them to be boys. Okay, you may get the boy, girls. Or you may get a boy, girls, boy. Or you may have a girls, boy, boy. You may have 3 girls. You may have a girls, boy. Then what else? So you may have girls, boy, girls. And finally, this is going to be boy, girls. I think that would be 8. 1, 2, 3, 4, 5, 6, 7, 8. Again, for each child, you have 2 possibilities, girls or boys. So we have 3 cases. So 2 times 2 times 2 would be 8. Okay, any question? So what's the event you are interested in? Interested in having 3 girls. So in this case, your A is going to be only 1 case. It's going to be girls. Okay, so this is going to be the case. So the probability of getting A is going to be N of A over N of S. You have only 1 possibility for A, but you have 8 possibility over here. Okay, so 1 over 8 is going to be the probability. 1 over 8 is 12.5% if you like that. You can write it down, in this form. So there is 1 out of 8 possibilities that you may get all the children, 3 children to be girls. Okay, so it's going to be type 1. Any question? So I give a break, we come back. The second one is very interesting for the rest of the course, but this is nice. You get a couple of problems, that we're using this one. So it's almost 11:20, 21, 10 minutes. We come back and we do the other 2. We try to finish this section. See that. Okay. So we talk about this is classical probability. Okay, so just usual probability that we have. A set would be given to you. You know, you identify the number of the elements in A divided by the total number of in the sample space, and you get result. Okay. So I told you this is going to be called classical probability because we are not going to argue about the probability of the basic one that we're going to have. We give everybody, we assume that, you know, all the events are equally likely to happen, if you like. Now, the second one. The second one is, remember the information that we collect. Remember, we are going to collect the sample, or the information would be given to you as a frequency distribution. Remember frequency distribution, we get the classes, and the frequencies. So we want to know how we're going to take care of the probability of event when it's related to the frequency distribution. This is much more popular. And when you are out of this chapter, this is going to be the only probability that we are going to use. So pay attention to this one. And its formula is nothing new because we already got the relative frequency probability. So what's going to be relative? Remember, we did the relative frequency before. What is going to be relative frequency? Relative frequency probability. That's the one. You see the difference between this probability and the other one is that in the other one, we talk about it that, you know, you are not going to argue about the probability of having those events. For example, if you toss a coin, there is a 50% chance that you get a hair or 50% chance you get a tail. But in this type of the probabilities, you are going to learn it, okay, through the experiment, if you like, through the repetition, which is the frequency here, to get to these numbers. And if you want to see a piece of history, for the first time, there is a guy, his name is Karish, I think that's it. He's an English. He was an English mathematician. He was taken in prison during the World War II in Poland. And while he was in prison, what he did, he tossed a coin. Okay, he tossed a coin 10,000 times. Okay, 10,000 times. And then he recorded the number of the times that you get heads. He find out that out of 10,000, 5,067 times you are going to get the heads. So he just concluded that probability of getting a heads, if you like, is going to be what? Is going to be the number of the times that you get the head, 5,067 divided by 10,000. And this would be almost 50%. So that gives you 50.67%. So with this repetition, if you like, with this experiment, he got the fact that yes, if you toss a coin, there is a 50% chance that you get a head. You see this type of arguments that we're going to have. The other one, I call it expected one. So you expect, if you toss a coin, you expect that there is a 50% chance that you get a head. But this one, they refer to it as the empirical one. Empirical one means something that you learn through the experience. So that's a kind of foundation of this type of probability method, if you like, to get it. So over here, this is going to be just a frequency of that class, for example, frequency that you get the heads divided by the total number. They call it the relative frequency probability. But basically, in this format, you are going to be given a probability distribution table as we did it before for those grouping methods, remember? So this is going to be the argument. Given a table, a frequency, given a frequency distribution, those classes and the frequencies, the probability. Probability is going to be relative frequency. Remember, relative frequency was what? Was frequency of one class divided by total number of frequencies. Is the same thing. So the probability of an event, being in a given class, being in a given class is going to be called, okay, is going to be called frequency is called relative frequency probability. Okay, frequency of that event is going to be in that given class. So the formula is the one that we did before. So the probability of having A in that class is going to be equal to, okay, it's going to be equal to the frequency of that class. You see, this is it. It's going to be frequency of the class containing A divided by the total frequencies, total frequencies. Or as we did it before, this is it. Remember, P of A is equal to the frequency of the class divided by total number of the frequencies, sigma F. Or, in short, frequency of A is going to be what? It's going to be F over N. F over N, again, we emphasize that where F is the frequency of the class, is the frequency of the class, and N is the total number of frequencies. N is the total frequencies. So it's nothing new, it's this one that we did before. This would be very popular when we get to the function formation of these ideas. This is the only one that we're going to use. Okay, any question? Now pay attention to this next example. This example is very important, and the expression that I'm going to use in this example is going to be used through this course. Okay, and you don't have this type of examples directly in your book at this level. So that's why you have to pay attention with this, and we put a couple of them in your practice one so that you're not going to miss it for future. So the case, this is it. I should give you a kind of a frequency distribution table and some questions. The thing that we're going to propose here is we are going to look into the maternity patients in a hospital and the number of the days that they stay in hospital. Okay, so this is going to be the case, and we ask some probability question. So let's have the information first. That's it, hospital. Get the data first. Hospital records. Hospital records that the maternity patient maternity patients records that maternity patients stayed in the hospital stayed in the hospital for the following number of the days. Or the number of days shown below. Shown below. Okay, so this is a situation we're going to have. We get the chart here. Okay, so that gives you the chart. So this is going to be number of the days or classes, number of or patients, number of days. Sorry, that's going to be number of days or classes. And over here is going to be number of patients, number of patients, which is the same as frequencies or frequency. Okay, that's going to be frequency. Number of the time that you get this case. So we have 3 days. The number of the patient is 15. So the frequency of this class is going to be 15. For 4 days, we have 32. Okay, for 5, we get 56 days. 6, for 6 days, we get 19 patients that is in the hospital for 6 days. And for 7 days, we get 5 patients. Okay, so the number of the patients and the frequencies are going to be the same thing. Okay. Now, what would be the question? The question is going to be, we're going to pick one patient out and we ask the following question. Okay, so we want to find the following probability. Okay, find the probability. Okay, find the probability that a patient, okay, a patient stayed in hospital okay, stayed in hospital for these following cases that we're going to have. Okay, so I'm going to put it here because I need this information to have it. Oh, I'll go to the next page. Are you done? So we pick one patient out and we want to find the probability that patient is staying in hospital for the following cases, okay? So the case 1 is that the patient stayed in hospital for exactly 5 days. Exactly 5 days. That is going to be case 1. Okay, the case 2 is that the patient stay in the hospital less than 6 days. Okay, the third case is that the patient stayed at most 4 days. Okay, and the fourth case is that the patient stayed in hospital at least 5 days. These expressions of exactly, you see these 3 expressions that we're going to have over here, you see exactly, at most, at least. Are going to be used through this course when we get to the problem of the probability and okay, on this, okay, on the following chapters, always this is going to be our case. Okay, the formula that's going to be used for the probability is going to be that frequency, okay, relative frequency the probability. So the solution is going to be, so basically the formula is probability of A is going to be equal to the frequency of the class that containing the A divided by the total number of the frequencies. Okay, so this is going to be your formula to start with. Okay, so the first thing you need to do is you have to go back to your table and give us the sum of all the frequencies, sigma f. Okay, so if you go to the table and you add these numbers together, okay, if you add this number, the total is 127 patients, the total number of the patients that you know that you did have in this survey. Okay, any question? Now we get the question one by one. Okay, so what's going to be the first case? You see, the first case, you want to find the probability that a patient, the event that you have, the probability that a patient stay in hospital exactly 5 days. You see, you have a look here, 5 days. So exactly 5 days, you have 56 patients. So this means in this case, the frequency of the class is 56 divided by the total numbers of frequency, which is 127. Okay, because this is exactly 5. Exactly 5, you get 56. Okay, so this is going to be coming back here. Okay, so we know that the sigma f, we check the sigma f, n equal to the sigma f, if you like. This is 127. Now we can go and answer the questions one by one. So the first part, exactly 5 means probability of A is going to be equal to the, I repeat it again, F over N. The frequency of this class is 56. Okay, and the total number is going to be 127. Okay, you cannot simplify it, you can leave it as is, but if you use your calculator, give us in percent, that give you a better idea. Okay, so it's going to be, it's going to be 44% or 44.1%. We can run it if you like. It's not a big deal for this case. Okay, so this means if you check one of the patients, there is 44% chance, 44% chance that patient is stay in hospital exactly 5 days. And that would be good for the manager of the hospital because they want to know. They can be prepared if you like to get this result. Any question? So when it's exact, it's just one case. Now, what's the second case? The second case, the patient stays in hospital less than 6. You see, less than 6 is like this. You see, you want to find the probability if X is going to be number of the days that patient stay in hospital. You want this one to be something like, less than 6. Less than 6. You see, that's going to be your question, just for your information. So when X is less than 6, remember X is the number of the days. So what's going to be the possibilities? Any suggestion? If X would be strictly less than 6, what is the possibility for the values of the X? Remember, X is a number of the days. Any suggestion? X less than 6 and X is the number of the days. So less than 6 would be what? You see? When it's a less than 6 means, it can be 5, can be 4, or can be 3. Okay, less than 6, and X is the number of the days. So since it's a less than 6, so this means you have to consider the number of the patients that are going to be staying 5 days. Okay, 5 days, 4 days, and the 3 days. It's going to be 5, 4, 3, 2, 1, 0. But in this case, you have it only up to the 3. So what you have to do is you find out how many patients would qualify for this case, and this is it. For the 5 days, you get a 56 patient. For the 4 days, you get the 32 patients, and for the 3 days, you get 15 patients. So the probability in this case is going to be, I say that's it, what's going to be probability of the event A is going to be equal to the number of the patients in hospital for exactly 5 days is 56 frequency plus for 4 days you have 32. Okay, and for the 3 days you have 15 divided by the total number of the frequency 127. Any question? You add them together. If you add the numbers on the top, that give you 103. It's going to be 103 over 127. You can use your calculator, that give you 81%. So probability of A in this case is going to be what? 81%. So this means there is 81% chance. There is 81% chance that a patient would stay in hospital less than 6 days, which is going to be very, very, very high probability. Any question? So you will see this type of ideas in future when we go to the function format. Less than 6 means not 6, anything less. So x is the number of the days, is an integer, so it would be 5, 4, 3, 2, 1, 0, if you like. But in this case, we did have only up to the 3 days, so that's why I stop. Okay, that's case 2. Any question? Now, case 3. Case 3, you got to be careful for this. You want to check it when the patient is staying in hospital. That's it, case 3. Case 3 is at most 4. At most 4 means 4 and done. You see, at most is the end, if you like. You see, at most is going to be the end. So this means your x, the number of the days, must be less than equal to 4. Okay, at most 4 means 4 and done. 4 and done, so x less than equal to 4. So what's going to be the possibilities? If this is going to be the case, so the possibility that you're going to have, you can have the 4, and then you can have a 3. Okay, you can have 4 and 3 because it's going to be 4, 3, 2, 1, 0, but you don't have 2 and the 1. Okay, so you have to go and check how many patients stay in hospital for 4 days or 3 days. If you go and check your table, this is going to be the case. You have 32 patients. 32 patients stay in hospital for 4 days and 15 for 3 days. So it's got 32 plus 15. Okay, so the probability of your event, in this case, probability of A is going to be equal to, for the 4 days, you get the 32, and for the 3 days, you get a 15 divided by total number 127. So this is going to be, you add them together, and that gives you 47. It's going to be 47 over 127. And if you simplify it, that gives you 37%. So probability of A is going to be 37%. Okay, so there is a 37% chance. There is a 37% chance that the patient will stay in hospital at most 4 days. Any question? So remember, at most is the end. At most 4 means 4 and less. 4 and less. That is the case 3. The case 4 is at least 5. You see, at least 5, at least is the beginning. And say at least 5 means 5 and up. You see, 5 and up. So x is greater than or equal to 5. At least is the beginning, at most is the end. Okay, so that would be 5 and up. What's going to be the possibilities? You can have x equal to the 5, 6, 7, 8, etc. But you have at most 6 days. Oh, we have the 7 as well. So x can be 5, 6, and 7. Okay, if you go to the table, you see the number of the days that we have. So this is it. We can have the 5, 6, and 7. For the 5 days, 56. For the 6 days, 19, and the 5. So you add these numbers together. For the top, and so the probability of A is going to be equal to, at the top for the 5 days, we have a 56 patients. Okay, for the 6, we have 19 and 5 divided by the total one, which is 127. So the result is going to be 80. Okay, 80 over 127. And this would be 63%. So there is 63% chance that the patient would stay in hospital for at least 5 days. Very interesting problem. And from now on, you're going to see this expression. So get to know them and be ready to apply it, especially for those at least, at most. So 3 expression, as I told you, that we are going to use from now on when it's going to be exact. When it's exact, it's just one number, okay? Is going to be one number only when it's exact. But when it's at least, this would be just the beginning, okay? At least going to be the beginning. And at most is going to be the end, okay? And we give you some, you have one in your practice one. In your book, they talk about this type of problems in future, but you want to get it right now so that if you know, you'll be prepared for it. Okay, any question? So that's a relative frequency probability. So it's going to be used when you have these type of tables for the frequency distribution. That classic one, we take care of it for the ordinary problem that we have. But if you have a grouping information, you have to use that, the new one. Okay, so that's a case 2. Case 3 is easy, subjective probability. The subjective probability is just an educated guess. You see, you go to your doctor office and your physician, they may tell you that, you know, there is a 40% chance that you need an operation. So the probability of that event is 40%. You are not going to question it, and you don't need any formula because you trust your physician. So that's an educated guess. Or you watch the news, they predict that tomorrow there is a 60% chance of having rain tomorrow. Then you believe it. So these are going to be called subjective probabilities, okay? So it's just for information. You are not going to have any problem on this one. Okay, so what is going to be subjective probability? So it's just educated guess, a person. Okay, a person makes an educated guess. Educated guess of the chance, okay, of the chance that an event will occur. Okay, and you accept it. That's good. Okay, if you want an example, it's going to be this one. For example, if a physician, you know, if your physician telling you that okay, a physician telling you that there is a 30% chance that the patient will need an operation. Will need an operation. Okay, so this basically means that the probability of this event. So the probability of this event is going to be 30%. So when we call it, subjective probability. And some people, they use it in everyday life. That is going to be, it's going to be the case. Any question? So this is 3 types of probability that we can have, okay, to find the probability. And as you can see, what I did really is I just introduced a function. So then event would be given, we assign a number to that event. That number is going to be a probability. So we have a function. Okay, we have a function and we call it probability function. You see some people, when you talk about it, they say a statistic is a difficult course. No, a statistic part is very easy. The probability part, if you go to the advanced level, the probability is the mathematics of the statistics, and that part is difficult. If you want to prove theorems, it's all probability. In mathematics, these type of functions, we are going to call them a measure. Okay, and there is a branch of mathematics that we call it measure theory, which is very difficult. If you want to take any master program, master degree, or the PhD, you have to go through that course, which is a very tough course. Okay, but for example, I'm a pure mathematician, so I'm not to call them probability. I call them a measure. Okay, this is it, measure. It's going to be a function, measure. And the measure theory is one of the interesting branch of mathematics. If you want to take any course, any advanced research in mathematics, in physics, you have to take this course first, which is a difficult course. But, it's a nice one. I've taught this one several times. But what's going to be the idea? The idea is going to be, you see these measures or the probability, they are a special functions. You cannot pick any function. You see, when we talk about the function in algebra, for example, f of x is equal to the x squared minus 3x plus 1. That's a function. The question is going to be, is this function can be a probability of an event? The answer is no, because this probability should satisfy some special condition that will help you quite a lot, and you must know it through this, through the course, if you like. So what's going to be the condition that this function, the event, the probability of in the event should have? You see, I'm going to list it for you. So we may give you a function, you may get a situation that they may ask what's wrong with this one, and you just look at the probability. You see, for example, the probability cannot be a negative number. It must be positive all the time. You cannot say that the probability of having rain tonight is negative 20%. No, it must be a positive number. It must be between 0 and 1, or 0% and 100%. Okay, and the second case is if you add the probability of all the possibilities in one experiment, the total must be 1 or 100%. So we call them requirements. It's very easy, but it costs you one problem for your next quiz, and in various parts of the course you are going to use it. So pay attention to this one. So the question is any function a probability? No. The function is going to be probability if satisfy the following 4 conditions. Okay. So in your book, you have various cases that would be related to this book. If A is an event, okay, an event, then P of A, okay, the probability is a number, okay, that satisfy the following. Okay, satisfies the following condition. The following conditions. So if you don't have these conditions, then P of A doesn't make sense. The first condition. This number must be between 0 and 1 all the time. 0 less than equal to the P of A less than equal to 1. So you cannot say that the probability is 1.5. If somebody's at P of A equal 1.5, you say, oh, what are you talking about? At most, it's going to be 1. Now, in percent, it's going to be 0%. P of A, you know that the 1 is the same as the 100%. 100%. So that's the first condition. If somebody said the probability of getting A in this course is 110%, you're going to question it. See what I mean? The probability is at most 100%. In everyday life, of course, you talk about 150%. They may charge you in your credit card, okay? Or you may charge you in your mortgage, on your loan. But in the case of the probability, no way. It's always between 0% and 100%. Be careful. Okay, that's going to be case 1. Any question? Case 2, when you are going to get the 0 and when are you going to get the 1? You see, for the case 2, if your event is never occur, it would be almost impossible to occur. In that case, the probability of getting that event is 0. Okay, so if an event A cannot occur, then the probability of that event is 0. Which of A would be 0. That's it. Okay, so you may be asked, what is the probability that Thanksgiving is going to be on Wednesday? 0. Because the Thanksgiving is going to be on Thursday. You see, that's this type of thing. You have a couple of nice ones in your book. So don't be surprised. So if it's going to be impossible for A to get the A, so the probability of A is going to be 0. Okay. Or, you know, there are different ways, you know, one of them in your book is, if you roll a die, what is the probability of getting a 7? 0. Because if you roll a die, you get a 1, 2, 3, 4, 5, 6, you never get the 7. Okay, so it's happened, and we call it a probability would be 0. So probability can be 0. Okay, any question? So when are you going to get 1 or 100%? If you are quite sure that this event can happen, in this case, the probability would be 100%. So the third one, if, if an event A is certain to happen, certain to occur, in that case, the probability of that event would be 1 or would be 100%. So there are cases that you may get 1 or 100%. For example, this is again in your book. What is the probability that you've been born in a day ended with the letter Y, for example? Okay, what's the probability that you've been born in a day ended with the letter Y? You know that every day of the week would end it with a Y. Monday, Tuesday, Wednesday, Friday, Saturday, etc. So the probability that you're going to be born on those days is 100%. Okay, so these are going to be, you know, the case. So there are cases that you may get 100%. So in this case means this A is the same as your sample space. Okay, so this is going to be the one, but the more serious one is just the last one. And the last one is going to be, you see, if you do a probability experiment, the probability of all the possibilities, the sum of the probability of all the possibility must be equal to 1 or 100%. And that's important. We're going to use it in future. Okay, so if, that's it, sorry, not if, the sum. Okay, the sum of all the probability, the sum of the probabilities of the outcomes, all the outcomes of all outcomes in the sample space, is simply 1 or 100%. Okay, and this is the way we write it down. Say sigma of P of A, means all the possible probability, is equal to 1 or is equal to the 100%. So for example, if you say the probability of having rain tonight is 30%, then the probability of not having rain tonight is going to be 70%, because 30% and 70% would give you 100%. Okay, so this is going to be a situation. So if you have a function, that satisfies all these properties that I talk about it, in that case, that function would be a probability. Otherwise, it's not. Okay, I just give you one problem because you have this one in your book, and we finish this section. Okay, any question? So don't be surprised if you see this type of problems. Example, and this is problem 1 in that take-home quiz, practice quiz that we are going to post. We want to know which of the following numbers cannot possibly be probability. Be probabilities. What is wrong with it? Just explain it. Probabilities. Okay, the numbers are part 1. It's 0.462. It's the first number. The second number is a negative 0.201. The third number is 1. The fourth number is 5.6. And the other number is 3.5. This is 0. And the last one is 115%. Remember, the probability must be a positive number between 0 and 1. That's going to be the case. Yes or no, the first one? It's a 0.462.
Yes.
Yes.
Yes, that's it, because the positive number is less than 1, 46.2%. Nothing wrong with this one. Second one, negative
No.
point. No, it's a negative. Okay, 1.
Yes.
Yes, 1 is 100%. 5.6.
Yes.
Yes, 5.6 is yes, because it is less than 1. So that's going to be 1. 3.5.
Yes.
3.5. Jennifer, you're right. Any other suggestion? No,
No.
you're wrong. Sorry. 3.5 is bigger than 1. So this is not. Okay, 3.5 is bigger than 1. The probability can be at most 1 or 100%. Okay, that's 1. 0, nothing wrong with the 0. We can have 0%. Okay. 115%?
No.
No.
No, because probability is at most 100%. That's it. You are going to have a situation that, you will get this number. Then you have to be careful, you see, not a direct question. So you may, we are going to propose something to you, and then you find it, and then you say, oh, my answer is 1.6. So whatever it is, then you are going to say that that's going to be impossible. You see, if you get, possibility of getting, winning a lottery ticket, for example, if you happen to be equal to the 115%, so probably you missed it in your calculation, something wrong. It's not going to be possible. Okay, so this is the way we're going to use it from now on to checking the mistakes. Okay, that's a foundation of the probabilities. Okay, that would be quite interesting one that we're going to have. Now, what we are going to do next is I get the post a take home practice one for you. We go over that practice one on on Thursday, but we have the other thing that we have to do. Something we call it rules of the probabilities. You see, these are only a single event. We can combine them together using or and. There are quite a lot of 4 rules, if you like. I'm not going to get to those rules, but there is only one which is easy. I'll talk about that one first, okay? And I put, because there are 3 problems of that one on your practice quiz. That's a very easy rule. We call it complementary one. But we don't get to the main one before your quiz. We don't give you enough time to be prepared, okay? So just one rule. This is one formula. I didn't get time, otherwise I talk about it today. Then we practice, okay? Practice for quiz number 2, and then after the quiz, quickly we finish this chapter in one lecture, okay? That's going to be our target. Okay, any question?
I had a question.
Yes.
So are you going to be grading the take-home quiz, the extra credit one?
Yeah.
And then another question for you. So it's extra credit points, but are they like homework points, or are they like quiz points, or?
You repeat it again. You say extra credit point.
Yeah. So are they just going to be like homework extra credit points? Or are they going to go towards the exam or?
No. It's extra credit. You can add it to your exam, whatever you like. At the end,
okay.
we add it to your total.
Okay.
That's extra. You see, it's besides of whatever you get from the syllabus. So
Okay.
if your total is going to be something like, the total on the syllabus, I think it's 400 or something, 450. So your extra would be added to that 450. Okay. But if you like, now you can add it to your test so far. But it would be there at the end. It would be 20 points. I think so far you get 4 points. You are not going to get the take-home one for the quiz because the quiz is short.